Hello everyone and welcome back. Today we're diving into the mind-bending world of mathematics, where simple concepts hide infinite mysteries. You think math is just numbers and equations? Think again. I'm about to reveal 5 mathematical phenomena so fascinating and mysterious that they'll completely change how you see reality itself. From infinite decimals to twisted surfaces, prepare to discover that mathematics isn't invented, it's discovered. So get comfortable and let's explore the universe of numbers. Let's start with perhaps the most famous number of all time, pi. This mysterious number embodies the very idea of infinity hidden in a simple circle. The relationship between a circle's circumference and its diameter seems trivial, but its exact value never ends and never repeats. For centuries, mathematicians have been calculating its decimals, and modern supercomputers have now reached over 100 trillion digits. This number serves in physics, engineering, and all the geometry of human culture. Archimedes was the first to approach it with precision, long before the appearance of zero or algorithmic calculation. What's fascinating is the poetry of order hidden in chaos. No sequence repeats, yet this number governs the circle, the ultimate symbol of perfection. In nature, waves, soap bubbles, and planets obey pi. It's what allows us to measure the beat of a pendulum, the trajectory of a sphere, or the cycles of seasons. Its omnipresence is silent proof that mathematics is not invented, but discovered. Artists and poets have exalted it too. It represents the frontier between what we can calculate and what we can only approximate. Here's the mind-blowing part. Pi appears everywhere in the universe, even in places that have nothing to do with circles. It shows up in quantum physics, probability theory, even in the structure of DNA. Scientists have searched for patterns in pi's decimals for centuries. Is there a hidden message? Some believe that if you go far enough, you could find any sequence of numbers, your birthday, your phone number, even the complete works of Shakespeare, encoded in binary. This is called the normality hypothesis, and we still don't know if it's true. After millennia of calculations, pi keeps its mysteries, like a laughing enigma in the universe. Pi, the number that proves infinity, lives in every circle. Now let's talk about something that completely defies common sense, the birthday paradox. You'd think that in a room of 23 people, there's very little chance that 2 share the same birthday, right? Wrong. The probability actually exceeds 50%, and with just 70 people, it's a 99.9% certainty. How is this possible? It comes from the fact that comparisons happen between all possible pairs. In a group of 23 people, there aren't just 23 chances, there are 253 different pairs to compare. Mathematics reveals here what our intuition cannot grasp. Large numbers grow fast, very fast. This principle is the very foundation of information theory and modern cryptography. Behind this innocent game lies the power of combinatorial reasoning. Paradoxes like this remind us that our perception of randomness is biased. The striking coincidences of life often obey disguised probability laws. Think about it. How many times have you run into someone you know in an unexpected place and thought, what are the odds? The odds are actually much higher than you think. Mathematicians love these logical torments because they show how rigor can unmask apparent randomness. By exploring these patterns, we discover that the universe itself seems to function on a balance between probability and determinism. Games of chance, lotteries, improbable encounters, everything follows invisible structures. Casinos understand this perfectly, which is why they always win in the long run. And when you understand the paradox, you realize that cold calculations contain a form of pure magic. The birthday paradox is used in cryptography to break codes and in computer science to detect collisions in data. What seems like a party trick is actually the foundation of digital security. Mathematics, where coincidences aren't coincidences at all. Infinity is a concept as simple to state as it is impossible to grasp. The ancient Greeks feared it. They saw it as limitless chaos. It wasn't until the 19th century that Georg Cantor made it a rational object, and what he discovered changed mathematics forever. He proved that there are different sizes of infinity. The infinity of integers, the infinity of real numbers, and others even larger. This idea, initially rejected, was considered heretical by his contemporaries. Some mathematicians called him insane. Cantor showed that you could compare infinity to itself, and that not all infinities are equal. He created the notion of countable infinite sets, giving metaphysics new rigor. Imagine this: the infinity of all integers is actually smaller than the infinity of all decimal numbers between 0 and 1. Your mind is blown, right? His intuitions opened the door to set theory and modern logic. Even today, the question of whether there exists a smallest superior infinity remains open. This is called the continuum hypothesis, one of the greatest unsolved problems in mathematics. Infinity paradoxically structures the finite. Every calculation relies on the possibility of tending toward a limit. It's an abstract concept, but it permeates mathematics and quantum physics. Think about infinity. Every point on a line contains infinite points between it and the next. Every moment in time can be divided infinitely. Infinity is everywhere, hiding in the gaps between numbers. Thinking about infinity is contemplating the very dizziness of human thought. This symbol of eternity, drawn in a loop, is also an invitation to humility. We created a word to name what our mind cannot truly contain. Cantor himself went mad trying to understand infinity completely. Some infinities are so large that they can't even be described. Infinity, the concept that proves mathematics is stranger than fiction. Now let's talk about an object that's almost magical: the Mobius strip. Take a simple strip of paper, give it a half twist, and glue the ends together. You've just created a surface with only one side. If you trace along it with a pencil, you'll return to the starting point without ever lifting your hand. Mind-bending, right? This idea, proposed by August Ferdinand Mobius and Johann Listing in the 19th century, revolutionizes our vision of geometry. It's a non-orientable structure. It defies the distinction between inside and outside. There is no inside or outside, just one continuous surface. Mathematicians and artists have seized upon it. Contemporary sculptors use it as a symbol of continuity and infinity. In electronics, certain transmission belts adopt this model to limit wear. They last twice as long because the wear distributes evenly across the entire surface. In biology, DNA structure sometimes presents similar configurations. This strip proves that even a mundane object can hide a profound idea. It connects geometry, topology, and philosophy. A single band generates the unity of the world. Here's something even crazier. If you cut a Mobius strip along its center line, it doesn't split into two strips. It becomes one larger strip with two twists. And if you cut it a third of the way from the edge, you get two interlocking strips. The Mobius strip keeps surprising mathematicians even today. A child playing with one unknowingly creates a metaphor for the cosmos. Everything is connected. Everything returns to itself. Behind the simplicity of glued paper lies mathematical beauty that evokes a perfect poem. The Mobius strip appears in art, architecture, and even in the recycling symbol. It represents the endless cycle of renewal. A twisted piece of paper that reveals the topology of the universe. And finally, let's talk about the number that revolutionized human civilization: 0. This number is a much more recent invention than you might think. The Romans ignored it, the Greeks mistrusted it, and it took ancient India to give it its full meaning. Indian mathematicians saw it as a sacred symbol, the fertile void from which everything emerges. The word 0 comes from the Sanskrit shunya, meaning both void and latent infinity. Its introduction to Europe, thanks to Arab scholars, revolutionized calculation and thought. From merchants to philosophers, everyone had to adopt it. Without 0, no modern economy, no computer program, no differential equation would exist. This little round symbol is the key to our digital universe. Yet it represents nothingness, an idea that fascinated thinkers for millennia. The nothing became a number. It allowed us to count debts, to predict, to encode absence. Think about it. Before zero, how did you write, "I have nothing"? You couldn't. Zero gave birth to science as we know it. It's both the origin and the end, the silence and the foundation of mathematical language. Zero has some bizarre properties. Any number multiplied by zero equals zero, but you can't divide by zero. If you try, mathematics breaks down. Dividing by zero creates infinity or undefined chaos. Computers crash when they accidentally divide by zero. It's the forbidden operation, the mathematical singularity. Its invention proves that human intelligence can transform the void into a universal tool. In the rigor of its perfect circle perhaps lies humanity's most beautiful intellectual creation. Before zero, there was no concept of negative numbers, no coordinate system, no calculus. Zero didn't just represent nothing, it unlocked everything. Zero, the number that contains all possibilities. So there you have it. Our journey through mathematics' most fascinating mysteries comes to an end. From pi's infinite decimals to the birthday paradox that defies intuition, from multiple infinities to the one-sided Mobius strip, and finally to zero, the number that changed everything. Mathematics isn't just about calculations, it's about discovering the hidden structure of reality itself. If you enjoyed this dive into the mathematical universe, don't forget to like, subscribe, and tell me in the comments which concept blew your mind the most. Do you know other mind-bending mathematical facts? Share them with us. The universe is built on numbers, and every number tells a story. See you very soon for more mathematical mysteries. Bye.